Okay, we are recording. Welcome everyone to the 17th podcast on this interview series. For this podcast, we have with us Harshita Sahijwani, who is currently a fourth year PhD student at Emory University, working at the cross sections of NLP and very other interesting domains. And one thing that I share with Harshita is we belong to the same undergrad college, which is the Rubai Ambani Institute of Information and Communication Technology. And I have known her and followed her research work since as a friend and as a colleague. And it's really inspiring to see that she recently won a 2019 Amazon Alexa challenge, which she would be talking briefly about. So I'll let Harshita introduce herself. Welcome, Harshita. Thanks a lot for agreeing to this podcast. And
Happy to
can you
partner. Mhm.
can you tell us a little bit about yourself and what are your current research interests and what are your projects that you are working on?
Right. So, like you said, I'm a fourth year PhD student at Emory. I got started with NLP, specifically the domains of recommender systems and IR while I was in undergrad. And yeah, I decided to get a PhD mainly because I thought I wanted to pursue those topics in like real depth. So yeah, that's how I ended up here at the IR lab in Emory. My advisor used to work mainly on information retrieval, but now he also works on a few related domains, one of them being conversational AI. And the Alexa Prize Challenge, like this year was our second time participating, but the first time was when I was in my first year. So that's how I got introduced to dialogue systems and all the open research questions that exist in this field. So yeah, since then, I've mostly been focused on doing research in that area. I've worked more specifically on the entity linking NLU aspect of it. So trying to identify what a person is talking about when they say, the president or um, the Harry Potter series, like trying to map it to the exact entity. And I briefly also worked on trying to do news search in the conversational setting. So just trying to get people articles that they asked for or that might be interesting to them. And for my thesis project, I'm right now working with Procter and Gamble to make a sort of a diagnosis plus recommender system bot. So the goal is for people to come and describe like their lifestyle and maybe what skin problems they have, and the bot will try to understand what their needs are and try to recommend maybe skincare products or dietary supplements and things like that. So, although it's domain specific, like I try to um, work on aspects that are the most interesting to me, which is just knowledge grounded dialogue. Trying to extract specific correct information from what the people are saying, and also trying to give responses which are both relevant and factually correct to meet the person's information need.
Wow, that's really interesting. Like you have a broad aspect of projects like being worked on right now. So like it gives you a much more holistic approach of solving. Like you can really say you would be an expert in NLP by the time you graduate. So that's really interesting. But talking about the Amazon Alexa prize for the 2019, can you talk a bit more in depth? Like, was the problem set much more of a research problem, or was it like a product specific? Like, were you supposed to build a product by the end of winning that competition, or was it a completely research domain that hey, you want to beat the state of art results by publishing paper? And can you be more specific on that?
Sure. So the way Amazon defined the challenge was, this is a competition where university teams compete against each other and try to further the state of the art for conversational AI. So yes, the goal of the contest was to contribute to dialogue systems research. In practice, it turned out to be both a lot of engineering work and a lot of research too. So uh, the structure of the contest was like we had 10 finalist teams based on proposals. So people just wrote what they were planning to do and they introduced like these are the people in our team and this is what we're good at. And based on that, they picked 10 university teams which were actually like their bots were deployed on the real Alexa bot. So if you say let's chat to Alexa, one of those bots would be picked up and you would talk to them. And the metric for advancing to the finals was that you had to be one of the bots with the highest user rating, or you could be one of the two bots which the judges thought, judges being, people from Alexa who work in this domain. So you could either be scientifically one of the best bots, or you could be one of the bots with the highest user rating. But user ratings were still an important component of the evaluation, and they were important in the contest in general. Like you could not be deploying just any bot which said uh, which didn't maintain a certain level of quality because it reflected on Alexa too, right? So if your bot had an average rating of less than 3, you would be taken off for some time till you were able to fix those things and be at par with the other bots. So because we had to make sure the bot was industry standard, it took a lot of engineering and a lot of manually written rules because, for, like among other things, you had to avoid at any costs not safe for work content or swear words or like really political statements. So you couldn't just retrieve from a pool of social media posts or news and just use it as is. You had to be really careful first about like censoring content, and secondly another big part was to be engaging. Like you could have a really good bot, but if the person starts getting bored, like the main goal of the contest was to build a social bot. So if you're not interesting, you're just reading out facts in a monotonous way, again the person would leave, even though like you have a really sophisticated recommender system, or like your responses in their content are good. So the being interesting part and not saying anything wrong part, they took a lot of engineering, um, and some research too. Like we got some insights about like one of the main problems in conversational AI right now. I mean, it's getting better now, but there aren't a lot of data sets from real users. Like what most people do is get workers from MTurk to talk about something, or like recruit participants, which is nice, but it's not really, like from the open world, a conversation between a human and a machine. So that was a really helpful resource for our research, like just to know what happens in the real world and what problems there are to solve. So even though we couldn't solve all of them during the contest because of the time constraints and everything else we had to do, it still was like a really enriching experience in terms of research as well, because there was some stuff which we could solve during the contest, and then there's so much more which we know yet needs to be done, but hasn't yet. So yeah, it's a really new field. Like right now, there isn't even like an objective metric that's agreed upon by everyone, saying this is how we'll evaluate, this is what we need in bots. So yeah, it's a new field, and it was a really nice experience just getting to know it and working on it, seeing the open problems. Um, yes, that's my description of the challenge.
Yeah, that's a really nice thing, which is, even though I just started, so I cannot speak really much about it. One thing that I really would say a downside of doing a PhD is losing out on the aspects of these specifications of building a product, which is if you are into a pro PhD project, you won't be able to think of these things like, hey, I need to censor the content, and hey, I need to make sure how users would be interacting with my particular product. My goal would be to just generate as much as good metrics that are beating the state of art results. So this is a very, like you said, this really builds us an experience. When we jump onto the industry, we can say that, hey, I have worked and I know what are the aspects of building a safe bot, even if they might be losing out on few particular accuracy values, but still they are relevant and much more useful. So that's a really nice thing that you shared. But talking about the participant, like how, like from a student perspective, how did you particularly know about, and how did you move on towards participating in such a challenge? Was it something that your lab or mentor that you came up with, or was it some student? And how can, in general, like I know not just NLP but other domains of AI also have these kind of challenges open now and then. A lot of companies put out these challenges and they have big bounties on them. How do you particularly go on towards participating in such a challenge? Is it like some kind of a proposal that you give and you get accepted and you are officially in the churn of making this uh, competition go live? Or like how, like just be, can you be more specific on the application process of this particular competition?
Sure. So the credit for discovering the contest and like deciding to participate and building a team goes to like our team lead, both from last year and this year. Like they were the ones who led the efforts to recruit people and um, put together a proposal. Like everyone gave inputs, but they were the ones who the ones driving the project. And there's several things to it. First of all, your advisor needs to be supportive of it, obviously. Like my advisor saw this as a good opportunity, and it's an area he's interested in. And also, with the data and the resources we got, and the opportunity to meet like other teams and people working on the same problem, he saw it as a good opportunity. And that's why everyone in the lab, we together went for it. Um, and the application process in this case was first a written proposal, uh, which is I mean, in principle it's like a grant proposal, because that's how they pick the teams which they would fund and like provide um, like money for funding to students and AWS resources for development. So similar principle to a grant, but they had a slightly different format. So there were 8 questions which we had to answer, from things like, what's your goal? What do you plan to achieve? And how would you make sure your bot is social and the best? Something along those lines. Those aren't the exact questions. But yeah, the proposal just saw if the bot we envisioned met the criteria that they were looking for in a winning bot, and just the expertise of the team and the uh, likelihood of them pulling off what they proposed. So that's how it went for this one. But I know of my lab mates who did participate in like other challenges which weren't as team based and not as organized as a competition. But there's a data set, they give you that, and you just come up with the best model and try to write a report on it. So as long as it's aligned with your research, at least my advisor has always been in support of that, and he's even proposed challenges to participate in. So yeah, I would say it's a good way of um, not doing research. But if you're the sort of person who feels more focused when there's a bit of structure in what you're doing, and like there are other people you're competing against, like I think it's fun that way when you're working on models. So uh, yeah, if you're okay with the trade-off between like the amount of engineering that it might be on top of research, I would say competitions are definitely worth going for at least once in your PhD.
Yeah, definitely. I would second a lot to that because I guess having competitions and having tentative milestones are really nice thing to expedite the process of your like in your personal terms it would be like your graduation, but in terms of also the whole idea of getting your project done at a much faster pace compared to what the NSF and NIH grants look like. They have those tentative milestones of 5 years, and I'm like like when I see those grants, and like we as students are like asked to make few contributions in terms of keywords that we put in the grants, and when I look at those grants they mature in like 2024, and I was like wow, well, like I should be graduated by then. If I'm like how would I get to work on, like why would I be writing grants for maybe the next 5 years? And deep learning changes every now, like every week we see new papers who are beating the state of art, and in that particular case, I would say having Amazon Alexa kind of competitions in various domains would be really helpful, and to all, maybe industry and students and whatnot.
Also, especially for someone who doesn't know a lot about that field, right? Like if you're already an expert, you know what problem you're working on, maybe it's less useful, but
Yeah, definitely. But deviating from the challenge a little bit, in the whole, like I'm completely still a very newbie in the domain of natural language processing. So, according to you, what are the very nice or maybe very fruitful developments that people are working on right now in the domain of natural language processing? From maybe like you can speak about from the academia side, because in I guess from the industry it varies specific to company, so we won't go there. But like what is the active area of research that you would say most of the people are focused on?
um, so I mean, it's hard for me to comment on NLP as a whole, but for areas which closely align with what I work on, um, knowledge graphs definitely are huge. So that's a really interesting thing people are working on. Like we have all these neural architectures being built specifically for leveraging knowledge graphs really nicely into existing like NLP models. And the reason that's getting so much importance right now is that um, so we have a lot of models which can emulate human like speech, and like we have good performance on a lot of tasks when it comes to the quality of text that you're producing, but in like dialogue systems and other systems where you generate text, uh, coming up with things which are accurate is still a challenge, and knowledge graphs are a really good way of making sure that you have the most recent knowledge, right? So you can have an auxiliary graph which is basically your repository of facts, and you make sure everything you say is consistent with that. So that's one area which is also like hot right now and interesting to me. So uh, everything from like efficiently building more graphs, incorporating graphs into neural networks using graph-based architectures, and that also leads to another area which is common sense reasoning. So once you don't have all the facts in your knowledge graph, you need to be able to infer stuff from what you have. So that's another really interesting thing people are trying to do right now. Given some facts, try to um, infer knowledge from it. It's a really old area. Like this has been going on for a really long time, but it still continues to be something people actively work on, and we are making like good. Not. I mean, I can't say good progress, but like there is a lot of nice new things happening. So yeah, that's another nice area.
Right, right. And I couldn't help but ask this question because, like, they decided like to do this podcast with you, and I knew you were a person who is actually working in the NLP domain. So I had to ask this question. A lot of people talk about GPT-3, and I see two sides. Like, there are people who are really optimistic about it, and they say this is the step towards achieving like generalized artificial intelligence, if at all they had the definition of what AGI really means. And On the other hand, there are scrutinizers who say it's a $175 billion parameter. It's like a dinosaur compared to us as humans, and it's really infeasible. It's impractical, and it has no real scope getting deployed. Like students and researchers cannot really work or have access as easily as what CNNs and other models have been. So like, do you have any general take on this, like being a researcher who understands at least how GPT-3 was built, maybe the technical aspects, and you have seen the bit side of your internships at Microsoft. So how do you, like, what is your general take? Be like, you can be more general or just say few words about GPT-3. What do you feel? Do you see the potential, or do you see it's still like we are still at square zero? It's no real progress.
No, we're definitely not at square zero. Like it is a huge accomplishment what they've done. I wouldn't claim to be like an expert on how they actually build a model. Like I could never train something as huge as that, and like even yeah, it's a really difficult thing to do in itself, even with the amount of money and data and everything they have. But I have been playing around with some applications of it, like dummy models of it. So there was this one where um, you like there was a Dungeons and Dragons GPT-3 website where you just you keep describing the adventure and it keeps responding. And I mean, I was blown away by what it could do. Like after I think the like eighth or ninth turn, it started being like it stopped making sense because like it couldn't keep track of the context, and plus I was saying some weird things which were hard to like they barely made sense, and it could not like give clever answers to that. But it's like at least in terms of like the quality of sentences, like how they were framed, and the fact that it could hold a conversation for that long uh, is definitely huge. And I mean, I agree with all the critique about like how it's not feasible in its current shape and form. um, and you could say in some sense it's just like because it's a huge model, that sort of makes it easy for it to do well. But and also but it's definitely like a step in it's a significant step. Like we know that at least with like not infinite but huge amounts of power we can accomplish this, and we can work towards like distilling it more and making it more production ready. Like one thing I personally like in my opinion, I don't think the like using general artificial intelligence is always the best way to go about a certain specific problem. Like for example, since I'm working on knowledge grounded conversations, uh, I didn't feel like okay, OpenGPT has solved it. Like it's it gives me inspiration for what to do, but when you're working on a specific problem, I find that there are other simpler architectures, but which are more specific to my problem, who would beat OpenGPT obviously because it's more generalized. And whether or not we really whether or not the focus should be on either inventing AI which can solve everything but are really expensive versus building models for specific tasks which uh, like although they can do just one task, they can do it really well. I feel like the second is a better use of resources in terms of utility, right? But obviously in terms of research, anything that's new and like something that can do things with machines which we never did is a positive contribution. And yeah, it's like
Yeah.
worth spending thoughts and money on, I feel so.
Yeah, I guess you made a fair point, because like they say, no research is bad research. I mean, it's definitely step towards something. It gives the impetus for some other people to at least think about in a particular direction, or maybe not think about that.
Right.
But a certain part of my thesis that I'm not actively working on, but definitely I'm interested in the interpretability of deep learning models.
Right.
And one of the major factors of not achieving interpretability is the number of parameters that we need to back, like just trace back and make sense that, hey,
Right.
once it gave the weight structure, what sense can I make of that particular trained model? And I could just not imagine the nightmare of a person who would be working or choosing a topic of research for interpreting GPT-3, because like it would be a, so that's like, I do agree that yes, it's a great research. It gives very funny and very nice, and maybe in some cases very intriguing answers. But again, to be deep, like when I say a lot of people scrutinize are the industry people, because once they have the reliability factor coming in when they're deploying in real world scenarios, a lot of people would be questioning that, hey, why did GPT-3 say this particular thing? And it would be a much more questionable factor. So I guess they have their own factors, but I'm just having pity for the people who would be choosing to work on the interpretability of GPT-3, because I see the interpretability domain from a CNN, like CNNs and all, like deep learning models from a vision aspect is much more mature. Like they have excellent results being done, because since it was started before the whole outburst of NLP, and still people struggle a lot into achieving these aspects of interpretability. So yeah, I mean, can you like, this might be off the topics that we discussed, but do you see any relevance of interpretability, or maybe like is it an active area of research in NLP? Like, are people curious about achieving interpretability of NLP deep learning models, or is that a concern, or like do you see any active research being done in that domain?
Uh, I do. I mean, there's definitely research being done. I went to like CIKM last year, and there was a group um, which did a really nice analysis of what BERT is doing at every layer. So I mean, there's definitely room for research like that, and it's really required and like really hard, as you said, but like really important too. So yeah, there is some work where people just focus on, take a model and try to interpret what it's doing. But in general, like an evaluation criteria which reviewers look at is, like when you propose a model, many reviewers will say that, it works, but you did no analysis of its interpretability. And like we don't really know what's going on, so they look at it as a negative in the paper. But those papers still get accepted because we know that interpretability is not an easy thing to analyze. So uh, I mean, is there scope for it? Yes. And if someone wants to work on it, I feel they definitely should, because um, one of the main things stopping us from productionalizing a lot of good ML models is interpretability. So um, yeah, definitely an important problem. Definitely people working on it, and definitely reviewers wanting people to work more on it. So, yeah.
Right. Right. And yeah, coming to the next question, I might be like, now I feel I'm asking in a very top to down approach these questions, but how did you build up an expertise or maybe an interest for domains that you're currently interested in NLP? Like, can you talk us about how did you found your interest that, hey, NLP something is really what excites me? Like, I knew while we were in undergrad you used to work, I might be you might be still working with the Rigby startup that was one of the professors at our undergrad college, Professor Saurish Dasgupta. And I knew it might be one of those points where you understood that, hey, NLP is something that really excites me. And can you talk to us about like how did you build up an expertise, like first of all an interest and later on an expertise that moved from various aspects like interest, development, research, and now winning challenges?
uh, right. I mean, I guess it just like I would say it was just a series of events which just happened to take place. And so like in my first year, when I joined undergrad, I obviously didn't think I wanted to do research. I enjoyed programming, and I wanted to, like, work on something interesting, just coding. Um, and like in my first year, I and two of my friends, we approached Professor Harshita Sahijwani. He was our programming professor, and also I knew like broadly that he worked on AI, but not really much about what he exactly did. Like, I was under the impression he worked on self-driving cars, which is completely not the case. But anyhow, we approached him and we just asked, like, can you give us something to, work on, or like, can you just give us tips on how to use this really long summer break to like become better programmers or just learn something new. And he was working on this paper about like using those what's it called, uh, like those the like the language of logic you used in discrete math to like encode information. So
Oh,
they were trying to use facts represented in like a logic framework and try to
kind
uh,
of an ontology or
yes,
something like.
yes, right. Yeah. So they had an ontology and they were trying to build so they were trying to extract an ontology from natural language text. And one of the components they needed was like they wanted to normalize all appearances of numbers. So 100 written as like just 100, or 100, or 100 books, or longer numbers and things like that. They just wanted a module to replace everything with an actual number. So he said, like, why don't you work on this? And yeah, that was my first exposure to NLP. Like, it wasn't very uh, heavy. Like, there was no machine learning. It was mostly rule based, and he just gave like some relevant stuff to read. Like, this is what natural language processing is, and like some papers on this particular problem. And that's how I got started with the domain. And although my involvement with that project initially was just development, he slowly started giving like more research oriented, open-ended problems to us. He was like, why don't you use topic modeling to classify these papers based on their topics? And like a little bit on like inferring, like determining if a certain sentence is implied from other sentences. So that's still an open problem, and we didn't really uh, particularly solve it in a very general way, but that was something I ended up reading about and working on it a little bit. So yeah, I guess that was enough to like, I wouldn't say I had like really extensive research experience, but it was enough to like get me familiar with the field and like really like it. So and I underestimated like how much effort and like what a PhD like entails, and like the amount of work, what it actually is. And so I was like, okay, I've always wanted to get a master's. I can spend 3 more years and like study this field really nicely, and hopefully work on that full time. So yeah, that's mostly how I ended up getting exposed to NLP and writing papers a bit and reading literature.
Right, right. That's really interesting. Yeah. That's, I guess, yeah. To me also, like I have seen people, or maybe a few of my personal experiences. Like it's always the undergrad, or maybe some kind of internships that serve as the interesting factor for you. Maybe it was these kind of side projects that really
Yeah.
that you started, and like you said, sequence of events happen, and you kind of uh, keep on connecting the dots, and maybe
Hmm.
hopefully the end dot is really nice. But yeah, um, like um, talking about your work experience, like you interned twice at Microsoft. Can you say a few lines, like how much difference of work environment that you feel? I mean, of course, you are like, to me, it's really interesting that your research lab at Emory itself is very product specific, because you have been working on a lot of other aspects of research. But do you see a major change while you work at research labs at Microsoft versus your lab at academia, or maybe at your professor's lab? And what kind of sweet differences or bad differences that you see in these two workplaces?
Right. Um, so I'll first talk about like my specific role, which was I was a research intern in a product team, which is the less common form of doing a research internship. So Microsoft Research is Microsoft's main research wing, right? So that's where scientists are just employed to do research that they're interested in, and just produce um, new models and write papers. So if you end up an intern with one of them as your supervisor, your experience is sort of different because then it's more research focused. Mine was again part research and part trying to meet the needs of the product team. So the team I was working on was like conversational search for Bing, and what they do is whenever someone writes an ambiguous query in Bing, they try to help the user uh, resolve it using like a slightly conversational interface. So if you write like Jaguar and they want the user to clarify, they'll be like, which one do you mean? Do you mean the car or do you mean the animal? So it's just this really small box which asks a question and gives options, and like the hope is to make it as naturally conversational sounding as they can. So yeah, this was a team which was like nicely aligned with my experience with Alexa Prize, because they were doing question answering in a conversational setting. It was different. It was a different setting in that they had a whole search engine to leverage this thing, which we didn't. Like we had to crawl our sources and make like small modules to answer each and every little thing, which I didn't have to do there. So in terms of like the resources which are available to you, industry is like leaps and bounds ahead. Like, and not just data, even tools like you feel like, okay, I need a model to I need a ranking model which works for short text. You can just see all the repository of people in Bing, and if anything that applies to you, they even write like the quality of code is obviously better than what uh, researchers usually put together. So it's really nicely modularly written, and you can just import it. And so implementing things is really quick in the industry. Getting data is like less problematic because they also have like hired human judges, and you just define a task and they label it for you. Obviously it's slower than automatically extracting labels, but it's a lot easier to do than working alone in your lab and trying to get like people to annotate stuff for you without spending like lots of money. Um, so yeah, resources is one major difference. Other than that, so in my particular experience, I had to try. I was trying to do research in coming up with a good way of producing these options for those questions they were asking. So it was a research problem, but I also had this requirement that by the end of my internship, I had to have some working model which could potentially be useful in production. So that's what differentiated my work there from my lab experience, is that there was a product involved. But from what I know of the experience of people who were mentored by someone at Microsoft Research, the goals, like the goal of writing a paper and just publishing good new research was the same as the lab. It's just that you had uh, more resources, like a slightly different way of doing things given those resources. And obviously it gives you like a view of what's really considered important in the industry. So problems that people at MSI are working on are definitely hot right now and like really useful to products, because they do have to convince like Microsoft to let them work on those, right? So it provides you with an insight into like what's really useful and relevant right now. So yeah, that's where internships help. Either it's a more product oriented one or even a purely research oriented one.
Right, right. Even yeah, I would agree to that because even I have found very less amount of big company names who have these research labs who actually try to focus on solving a research problem rather than building a or having just a revenue perspective out of it. Because I guess big companies like Microsoft, Google are privileged enough to first focus on the research aspect and maybe later on and maybe try out these things and later on if they see the potential to productionize it. So I guess it's getting best of both the worlds while working at research labs, which is a very nice thing for any PhD or ongoing researcher. But yes, that's a really nice insight to it. And talking about research versus development, and since you're working at slightly on the development aspect too also, uh, can you shed some light of like how has been PhD, like how has in general PhD been for you? Like, do you can you speak more on the pros and cons of doing a PhD? Do you find a lot of cons, a lot of pros hanging in there, or maybe enjoying in there? Like, what's the outlook after 4 years of doing a PhD? What like I ask this question from a perspective of a person who might be right now deciding to do a PhD or not do a PhD versus choosing an industry. And or maybe you can also talk about like doing masters. I knew you had a direct PhD program, but still you might have also sufficient amount of testimonies within you that says what masters really stand for. So can you speak more on that?
Right. Okay. So I mean, okay. So first of all, how has be, being in a PhD program been like? It's. I mean, I don't have a PhD yet, but so far it's been nice. Like I've enjoyed it. It's obviously been hard at times. Um, there's there are times when you have multiple deadlines at the same time, and if you're also taking courses, like it gets really stressful to balance everything. And at times it can be mentally hard because too many things, everything's falling apart. And yeah, so but yeah, you also learn from it and you get better at both handling pressure, handling big projects, working with people. So yeah, overall I would say I mean, it's been nice. I've been learning. And as far as like making a decision on whether or not to get a PhD goes, uh, I would say a PhD just trains you really well in the scientific process. So, what I mean by that is, say, like the whole, you know, everything you do from, say, you're working on a text classification problem, and of either for a course or out of interest or for a project or whatever. And you're like, okay, I have this new idea that if I incorporate this particular metadata from a knowledge graph, I can improve the classifier. And then you'll be like, okay, let me see if someone's done this before. And you'll consult literature. You'll see if it's already been done before, then good. You don't have to do experiments. You just know like what can go wrong, what's good about it, and decide if you want to do it or not to do it or build upon it. It's if it's not been done, you'll be like, okay, okay, so I have this new thing which might work, and you try to see what maybe someone has done something similar, and you try to gain insights from that, and then eventually you go for it and you implement your approach. and you would be like, okay, I have this thing, and let's see how it actually compares with everything else, like really in depth. So then you'll try to design an evaluation framework which fairly judges everything, and then you'll write your own analysis on, okay, I like my model does better on these aspects, but it's not so good on these other aspects where existing models did better. And yeah, and once you have that, you then publish your findings to a conference or journal or somewhere where people can see it. And again, someone else might find it useful and build upon it. So uh, if this whole idea sounds appealing to you, like trying to contribute to uh, all the literature we have on computer science research so far, just putting your ideas out there for people to use. A PhD will train you really nicely in doing this, because you'll have your advisor teaching from their knowledge and experience, and while doing, you'll do this a lot while writing your thesis, so you'll get a lot of practice, formulating ideas, evaluating them, communicating them. um, so yeah, that's the main thing a PhD gives you, which a master's would not. um, uh, it wouldn't be fair to say that someone with a PhD in ML is a better ML practitioner than someone with a master's, or maybe someone who just went to the industry directly after undergrad. I mean, everyone works on interesting things. Everyone has good ideas. Um, I mean, there are lots of people in the industry who really enjoy like working on ML problems, and but they want to focus their energy on productionalizing it, and then once they've done that, they want to move on to a new problem and try to build a product out of that. So in that case, you might not enjoy getting a PhD so much, because then it won't be exciting for you to do experiments and write about it. Like a PhD would still be useful for you to get even in that case, because it's still a way of asserting that you have a certain amount of expertise in that field. But yeah, that wouldn't be the main reason people usually get a PhD. It's usually to train yourself to become a researcher in the more uh, academia sense of the word. Um, yeah, so that's something that might help you make the decision. And as for whether or not a master's is helpful, um, again, for at least for the case of most of my friends, it has been like they were able to go from getting a more generic development job to still a development job, but at least in a team, and like focusing on, for example, HPC or ML, depending on what courses they took in their masters, right? So I mean, it's the same sort of debate whether, do you need to go to school to become a software engineer, or can you learn it on your own? So you could potentially learn the same things from experience as well. But if you do get a master's, it certainly won't be a waste either. Like in most cases, you will get a job which is more aligned with your interests.
Right. Yeah. Yeah. I completely agree. And now it kind of makes more sense on the aspect of the thing that you said about getting a training while you are doing a PhD. It's building an expertise, and you cannot just instill an expertise by just doing some kind of accumulated work. And I remember this was back in December 2019 when I was approaching my advisor. Like he's my advisor right now, but at that time he was just a professor, and I approached him like doing a PhD under him, and he said and being a very noob to him, I asked him like what would be my expected graduation date, because I did my masters from here and I want to do a PhD. So I was concerned about the credits thing, that hey, how much credits would I have to complete? And now that question seems very naive and very silly to me, but the way he answer like kind of becomes parallel to what you said, that credits are just a number that university or institution has came up with. But if you give 40 hours a week, what he said was like, if you are currently giving 40 hours a week and you start giving 60 hours a week, that doesn't decrease the amount of graduation, that doesn't decrease the graduation date. It's a timely process. Like, you cannot just expect that, hey, a 3-year graduation date, 3 or 4 years of graduation date would be reduced to 2 years of graduation. You cannot just learn certain things that take 3 or 4 years to maybe 1 or 2 years. So yeah, it's like you said, it's kind of a training, it's kind of an experience, building an expertise. And what he said, like, getting a PhD is having a certificate out to the world that says, I can work on anything, I can develop, I can do research, I can beat the state of art result or something, or I don't know, whatever it is. So I guess it comes with a cost of time. But yes, I also agree, like, masters is something, to me, I guess masters was a point that really allowed me to explore more options. I wasn't concerned about the time frame. All I was concerned was getting a degree and trying out new options, internships, working with professors, working at labs, being a uh, graduate services assistant, as they say. So it gives you option to not be inclined to any, or be obliged to do any of the projects for the rest of your degree. So I guess, yeah.
Right, like masters on the way to PhD is something I didn't talk about, but yes, like it's an opportunity to even get exposure to research and see, if you like it enough to.
Yeah, definitely. For me, it did backfire a little bit. After masters, I was a bit concerned that, hey, I know what PhD is like. Should I go for it? Way before I came for my masters, I was sure that, hey, 2 years of masters, 3 years of PhD later on, and like, this is what I want. But seeing the masters and the whole abroad experience, it did backfire. But yeah, I don't know.
I wouldn't say
uh,
backfire. You always learn new things, and it's okay to have different
Hopefully.
plans from what you originally thought.
Hopefully, I don't have to switch to some other thing later on a year. So that's the only thing that I'm hoping for. But yeah, that's all the questions that I had for you for this particular podcast series. But I'll completely end on a very open note, asking you about any general tips that you would have to a computer science newbie. Like, we won't be talking much more about research or NLP. Feel free to choose them if you want. But what would you say to a person who is just interested in normal programming, problem solving, and development throughout your experience? I know this would be much more specific to your particular timeline of events. I know you wouldn't be a pro development person or a software developer kind of a person. Like, pardon me if you would be, if you would like to call yourself. But feel free to take your approach and be on an open note. What would be your advice to any newbie in the domain of computer science?
Um, just to make it more specific, like are we talking undergrads or just anyone even before that?
I would say undergrads, because yeah, they would be only newbies. I expect they are not newbies if they are graduate students.
Okay. Uh, um, I mean, I would just advise them to explore a lot because like once you get into a job or once you get into a graduate program, that becomes your full-time thing. Like you're not gonna go home and spend time taking lectures just for fun or exploring new tools or something like that. I mean, you can, but it just gets a lot harder in terms of like how much time you have for it. And undergrad comes with a lot of time to just put into trying to see what you really like. So uh, yeah, just try to work on different projects, and if you find something that really does interest you, don't be afraid to pursue it further. And yeah, also, I mean, I know with the amount of like how competitive getting into a graduate program is right now, um, it's not unreasonable to like decide right from your first year what you want to work on and just keep building a research profile. And I mean, that is what it takes to get into the top PhD programs in most cases, but maybe try to balance it out with trying to learn a bit more about slightly related other areas, or also spending some time learning development on top of just pure research, just to um, be focused enough to be good for graduate studies, but still have some broad knowledge that could help you both in your studies and in the future when you have a job which requires, you know, research and writing, communication, coding. So yeah, just learn as much as you can while your undergrad life still permits you the time to explore.
Right, right. Yeah, that's a very valuable advice. Yeah, definitely. I guess this applies to even graduate program too. I mean, just try to like now that I see like graduate program was much more flexible and less time consuming than PhD. I didn't think that PhD would be this time consuming. So in a very narrow aspect, definitely this applies to certain aspects of graduate studies. So yeah, but yeah, definitely keeping on exploring and trying out new things is definitely a great advice for anyone who is getting started into this domain. But thanks a lot. I guess that's the that's the wrap up of this particular podcast. I really thank you for agreeing to this podcast. It was really nice having you, and you definitely had some very interesting insights to the questions that I had, and I hope it was equally exciting for you to just answer these questions. But yeah, I'll also leave a link below to your homepage and your LinkedIn profile, so that people who are specifically interested into certain aspects of whatever we talked about, they might, or maybe they could reach out to you. So if
Sure.
that's fine with you. But yes, again, thanks a lot, and I hope this was a valuable discussion for everyone. Thank you.
Yeah, thank you for having me. Yeah, it's been nice talking about all this.